on page 2, we're going to start talking with vertex form. This is a form that you're probably less familiar with in terms of the equation. So for vertex form, you're actually really going to like this if it's in vertex form, because picking out the vertex is really quick. Okay, so the reason why it's called vertex form is because you're going to be able to see the vertex. Will you raise your hand if this looks semi-familiar to you, even if you're not sure what it means? So this is vertex form. We just looked at standard form. And the vertex is H, comma, K. So the vertex is a coordinate. Okay, when you are picking out the vertex, notice we have this minus H again. It is going to be very similar to what we talked about in chapter 1, where we talked about those transformations. Okay, so when you're finding the H value for the vertex, the H value is going to be inside the parentheses, and it is the opposite sign than what you see. Okay, the K value is outside of the parentheses, and you have to use the sign that's in front of K. What that means is if you have a plus K, okay, it's positive. You have a minus K, it's going to be negative. Okay, but this one is always going to be the opposite of what you see. You can also pick out transformations from this right away. And this tells you some special things about the graph. The first one is the A value. I'm going to write that over here. So that value in front it tells if the graph opens up okay, if it opens up, your A value is greater than 0, which means that it's what? Positive. Okay, so if it's positive, it's going to open up. Your graph, your parabola is going to look like this. Whereas if it's negative, it'll open down. You'll see your A value is less than 0. And it'll be opening down. These also tell you your transformations. So this here, do you guys remember what it is? The transformation? It's a type of shift. Remember what type?
Horizontal?
Yep. So it's a horizontal shift. And this is the one where it's the opposite, right? So if your H value is less than 0, it's going to the left, which is always what we know, right? If it's negative, it's going to the left. But when you plug the negative in there, what you actually see is the x plus h. And then if your h value is positive, it's going to the right. But then when you plug in a positive, you actually see that minus. So we are going to be identifying transformations. That's why we're going over this. Okay, and the plus k on the outside is going to be the vertical shift. Okay, so if it's vertical, if k is greater than 0, the graph is moving up, right? If there's a positive, k is negative, the graph is moving down, and you'll see that minus. Okay, so the horizontal transformations are always the one where there's something extra happening, right? It's the opposite, or you have the reciprocal that we'll talk about later. So when we do transformations, we compare it to the parent function. So for example 2, it says using the graph of, and that's going to be the parent function for quadratic, which is f of x equals, do you guys remember the parent function? What's the most basic quadratic function? Yeah, x squared. Great. Okay, so we're using that as a guide, and then we're going to describe the transformations and graph each function. So describe the transformations, graph each function. Okay, so our first equation is g of x equals x minus 2 squared plus 4. And then again, just notice on every example that we do, the first one, I'm going to give you directions. And then the second one, you're going to do this. So this is to help you too when you're doing your homework. If you're not sure where to start, go back to the first one and it'll tell you your steps. Alright, so for part A, step 1 is identify the vertex. Okay, this one you can just pick out by looking at the equation. So remember, the x is the opposite. So if we see x minus 2, that means your h value is positive 2. The k is what's on the outside, and that's just as you see it. So if it's plus 4, it's a positive 4. So your vertex is going to be the point 2, 4. Isn't that quick? Yeah. All right. So you can actually, I put this as step 2. You might actually want to do this as step 3 and do the graph as step 2, because then you can see the transformations. That's also something I recommended in chapter 1. So let's do that. We're going to get the table and graph. Okay, so for our function, we're going to make our table. We're going to put 2, 4 in the middle. Okay, vertex goes in the middle. And then I want you to see if you can pick your other x values, find the y's, and then graph it. Another thing that you can do to make sure that you graph correctly is check the a value, right? In this case, the a value is positive. It's a 1. There's nothing in front there, so it should be opening up. If I go 2 down, 2 up, this is a little bit different this time, so I can't just say it's 4. I have to plug it in, and I put my work for it down here. So I plugged in my 0, so this was 0 minus 2 squared plus 4, which would be 4 plus 4, so that's how I got 8 for this. And then for this one, I know it should be 8, so that's what I do in my head. 4 minus 2 is 2, 2 squared is 4, so that's 4 plus 4 as well. And then 1 minus 2 is negative 1, square that, you get 1, 1 plus 4 is going to be 5. Alright, and then for your transformations, you can compare that to the parent function. So remember, for the parent, you have f of x equals x squared. Do you guys remember what the 5 points are for that? What's your vertex? 0, 0. So you could think of it like the opposite of b. There's no b there. If you plug in 1, 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. Okay, so you can compare those. I'm going to graph this one. 1, 2, 1, 2, 3, 4. And then 1, 5. And 3, 5. 0, 8. And 4, 8. And then if you compare that to the parent function where you have 0, 0, 1, 1, negative 1, 1, and then at 3, where would I be for the parent function? What's 3 squared? What's, thank you. Okay, so that can help you see what's happening. So I look at the vertex, and then you can say to yourself, okay, the vertex is going over how many units, right or left? Going up or down, how many units? Okay? You can also use the graph itself. So you can decide. With the transformations, it is very easy to pick out from the graph. I always double check here. So if it's a negative 2, that's inside. I know it's a horizontal translation. 2 units. Now this is something that some of us had trouble with in the last unit. So remembering if it went right or left. So this can help you. Right? Now you can see it's to the right. And it is also going to be a vertical translation. And we can see it's moving up. So it's 4 units up. Okay, so we describe the transformations and we graph the function. Alright, so I want you to try B. Okay, so step 1, find your vertex, do your table. Okay, and then I do want you to graph with the parent function. I'm going to give you some time to do so. Okay, so for this one, your vertex, if you don't see anything on the outside, it's a 0. Okay, so your vertex is negative 3, 0. So the opposite of what you see here, so this is positive 3. So the h coordinate is negative 3. There was nothing added or subtracted on the outside, so the k is going to be 0. So then in the center of your chart should be negative 3, 0. So we're going to go 2 down, which would be negative 4, negative 5. And then 2 up, which would be negative 2, negative 1. Okay, so the x values are going to change just depending on what that middle is. And then I wrote out my work here, so negative 5 plus 3 is negative 2. Negative 2 squared is where I got the 4. Okay, and then I also graph this on the same as the parent function, f of x. You can see I labeled as the f of x and g of x. So that plus 3 is a horizontal translation, 3 units left. And that part is review from chapter 1. Alright, what questions do you have for me for part B? Did you guys remember to do the opposite for your vertex, or did somebody accidentally put 3? That's okay. I want you to make those mistakes now, and we'll remember them later. Okay, so the opposite of what you see inside there. Okay, and again, just double checking with the parent function so you can see that that is moving to the left. All right, let's flip it over.